guys, this is a hard difficulty level command of evidence quantitative information question. This is from the College Board Question Bank. Which finding, if true, would most directly support the claim in the underlined sentence? So I'm going to read all these first. I want to support the claim, it's the underlined sentence, but even this approximation of Grill's cell activity has less to do with similarity between neural networks and biological brains than it does to do with rules programmed into the networks. I got to read this whole thing because I really don't understand that out of context, and I want to support that claim. So let's read the whole thing. Neural networks are computer models intended to reflect organization of human brains and are often used in studies of brain function. According to an analysis of 11,000 such networks, Ryan Schaffer and colleagues advise caution when drawing conclusions about brains from observations of neural networks. They've found that when attempting to mimic grid cells, brain cells used in navigation, while 90% of the networks could accomplish navigation and related tasks, only about 10% of those exhibited any behaviors similar to those grid cells. So basically, these neural networks are doing what our brain does, but their behavior to get there, totally different. And only about 10% of them have any overlap with our brain, but even this approximation of grid cell activity has less to do with the similarity between the networks and biological brains. So it seems that biological brains and neural networks are very different than it does with the rules programmed into the networks. So they have rules programmed into the networks. I don't know what that means, but essentially it sounds like they're at a fundamental level, neural networks and our brains are very different, but we're trying to accomplish the same thing at the end of the day. The rules that allow for networks to exhibit behaviors like those of grid cells have no equivalent in the function of biological brains. Maybe. The networks that do not exhibit behaviors like those of grid cells were nonetheless programmed with rules that had proven useful in earlier neural network studies. I don't like the idea about earlier studies and proving useful. This sounds like out of scope to me and weird. And it doesn't get at the idea that we're supporting this idea that these two networks, that this neural network and the brain are at their basis different machines. And the only overlap really has to do with programming, not with how they actually work. Neural networks can often accomplish tasks that biological brains do, yes, but they are typically programmed with rules to model multiple types of brain cells simultaneously. Maybe? This one's actually really hard. Once a neural network is programmed, it is trained on certain tasks to see if it can independently arrive at processes that are similar to those performed by biological brains. This is just saying they're training it to see if it can do what the brain does. But I don't know that if I'm supporting the idea that neural networks and biological brains are fundamentally different, the idea that we're testing something like this doesn't seem to support that idea. These two structures are working totally differently. This doesn't seem to, this just says, oh, we're going to test it and see if it can figure it out on its own. But it may or may not do that independently in the same way that our brain does it. I don't know. Even if my brain isn't helping it. Neural networks can often accomplish tasks that biological brains do, but they are typically programmed with rules to model multiple types of brain cells simultaneously. I don't know why it has to be multiple types of brain cells. So again, I'm focusing on what do I need? I need to prove the idea that neural networks in the human brain, they're not alike, right? That seems to be the big emphasis here. It doesn't have to do with they're similar. They're not similar, you guys. They're very different. When I look at C, it says multiple types of brain cells simultaneously. This is not distancing it from the way that brains work. It's just saying that a single rule models. See, the problem with this is it's still modeling the brain. This is saying that they are just totally different. It's saying that biological brains and neural networks aren't the same. They do things super differently, right? That seems to be what's happening here. The rules that allow for networks to exhibit behaviors like those of grid cells, so this is their similar behaviors, have no equivalent in the function of biological brains. Yes, they have no equivalent. They are super different. So A really emphasizes the idea that these two things are different. It has less to do with similarity between their brains than it does with the rules. There are certain rules that we program and those are similar, but the structure of them is so different. This is really emphasizing that difference. And A is really emphasizing difference. This has no equivalent in the function of brains. This is actually saying that it models brains, but it just models like 5 kinds of the brain at once. But it's still modeling the brain. There's still some similarity there. So that's why I'm going to get rid of C at the end of the day. Again, D is just testing a notion. We don't know what the results of that could be. It could be that both function the same, even though this independently arrived at it, right? We have like some kinds of evolution where like 2 species evolve the same trait independently. Just because it evolves independently doesn't mean that there aren't related processes to how they do something. And this just has a weird out of scope earlier neural network studies. I don't know why proving useful has anything to do with supporting this idea that these are structurally different things. And A really re-emphasizes that. So that's your answer choice. This one was hard because it feels a little dicey. But what I recommend, again, find the claim that you're trying to support, find your keywords and really what the gist of it is. There's a lot of like back and forth in here. So when you have this back and forth and this push and pull, you've got to figure out which idea is the most important and then find information that's going to support that idea. And that's going to be your best answer choice. Cool. That was a hard one. If you want more awesome explanations of how to approach command of evidence questions, we have a whole lesson set on command of evidence on my online course. You can find it at SupertutorTV.com. If you are a tutor and you want more practice problems and you're here because you were trying to explain this to a student and figure out another angle to do that, check out SupertutorTV.com/educators. If you contact us, we will also give you free access to our Tutor Mode Basic if you get 3 students to sign up. We can also do group discounts for you if you are a tutor or teacher or educator. You can run group classes with our platform. It's perfect for solopreneurs, for teachers at high schools that are trying to run an SAT class. We have all the tools you need. We'd love to talk to you about it. Reach out. And if you're a student looking to self-study, we've got the materials that are going to help you elevate. We've even had a student score 1,600 using our materials. You could be next. Check it out.